All right, well, ladies and gentlemen, welcome and thank you for being here. As you know, I'm facing fierce competition from several excellent other presentations elsewhere. My talk's called D for Darwin, D for Drupal, and you may think that's a very strange name. First, who am I? My name's Erik Evrard, and I'm actually a physicist, not a biologist, as you might expect from the title. I've been doing physics since the 80s, and there we worked already with internet, with Mosaic, and I've known Drupal since 4.7, which makes it already a long time. And I work for one agency, which is a Drupal shop. I would call it a Drupal shop with brains, and we do typically the bigger stuff, bigger projects, integrations, challenging projects, with approximately 80 people, so it gives you an idea who we are. But why? Why this talk? What's the purpose of it? Well, I think our main concern is software sustainability. As we come into contact with these larger customers, we see these big legacy systems, and sometimes I wonder, these dinosaurs, will Drupal ever become a dinosaur itself? And also, on the other side, customers ask the same question before purchasing Drupal. They want to make sure sometimes that Drupal is the right choice and Drupal will not become a legacy system, a dinosaur, especially when they invest 5 or 6-digit budgets into a new system. And also we love Drupal. I don't want to see it perish, actually. So I'd like to know at least where will it head, what's going to happen with it. It exists now for 13 years. Will that last for another 13 years? Now there's a warning. And this is a very famous saying from a fellow physicist, Niels Bohr. Predicting is very difficult, especially about the future. And I think you get the pun of that. Now, despite the fact we can't predict the future, what we can do is study the past. And open source software hasn't been around for very long. Not long enough, but life has been around for very long. Life's been around for millions of years, and that makes it interesting because there are analogies, and maybe we can apply those on software and open source software development. So, again, disclaimer, I've already said it, I'm not a biologist, so anything I might say about biology may be scientifically not correct. And I'm not really a Drupal expert either, although I've been around with working with Drupal since 4.7. I'm not really a programmer, I'm not a developer, okay? Now, if you look at this picture, and most people who would see this, they would think, oh, this is a molecule. This is just some molecule with atoms. But then you, of course, because you know better, and you look at these little tags, you see straight away that this is actually a representation of Drupal. A Drupal of 2005, so it makes it 4.7 or 5, I'm not sure. Now this has been made, and this is a real molecule, right? This has been made with gauze, and gauze is actually a system that just reads a repository like Git or SVN, and it creates these beautiful images. It can actually make videos. So this is just one example, and it takes 5 minutes, so I'm not going to show it to you in full. This has been Drupal, as it was since 2000, made by Drush, evolving through time with adding complexity. And I'll just fast forward a little. This is around 2009, so we're in Drupal 6 already, going to Drupal 7. And if you see how quickly things have changed in the past few years. And you can see this online. This is really a fancy movie, very fascinating to watch for 5 minutes. And here we approach 2012 with Drupal 7 almost at its end and Drupal 8 coming up. And this is where we are now, to at least last year, beginning of the year. And as you can see, this looks really like the development of molecules. So I found this very fascinating. And this is just a few screenshots of the year with the last one. Now back to biology. Everybody knows Charles Darwin, of course. And in 1859, he traveled around the world on his boat and wrote after he returned this book, The Origins of Species. And of course, he went to the Galapagos Islands, and one of the discoveries he made is that there are turtles or tortoises, and they're very strange. They look like the other ones on the continent in South America and Africa, but they've got these huge, long necks. And why? Because the cactuses with the nice fruits that they like so much are really tall, so they've adapted to the local conditions, and that's what triggered his development of his theories. So his theories were, of course, based on the famous points, common descent and in descent with modification and natural selection. So we all, at least if there's a mother or a female and a male, we may inherit features from both or not. Well, one of the things related to the evolution theory is survival of the fittest. Many people use this term. Actually, it's a very wrong term, and I'm not going to into why, although we might think that survival is, of course, very important, and it happens, but rather we call this now an adaptive complexity, and that's what we are heading to also with open source software, adapting to conditions that are changing all the time. One thing that is actually new, and this is where biology is also influenced by people, is that we have a thing called artificial selection. We can breed, and it's been done for ages now. People, ever since they domesticated the dog, has changed the dog. It doesn't look like a wolf anymore. It looks very, very different. And there are actually many kinds of dogs. Now, one other thing I'd like to say, and this was an interesting link, I'm of course not the first one to make this link between biology and technology. 4 years after Darwin, this gentleman, Samuel Butler, who was actually a novelist, wrote a few interesting books, and one of them was about technology and how it would also evolve as biology. And he actually predicted in 1863 that computers, or at least machines, would overtake humans. Someday, humans would be less or would be inferior to machines. They would evolve, they would gain consciousness and all that. And I think this is pretty early to discover this. So he actually said technology and biology both are subject to the same laws of evolution. And we've learned more, of course, since Darwin. We've discovered DNA, and DNA looks very much like software code. If you look at it, it's a way of coding things in our bodies and our cells, and it looks like code, and you can change it now, and this is fascinating. Now, one thing that looks different is what we call radically new technologies, where there was no gradual evolution. It's true that some technologies have evolved. Some things have been improved over the years, but others have been really new. One example is a piston engine, and suddenly it was replaced by a jet engine. And it's not that a jet engine is an improved version of the piston engine, it's a new insight. So this happens, and this is something that doesn't really happen in nature. So there's a difference. That's our human creativity at work. Sometimes our inventions, certainly nowadays, are combinations of things. We call this combinatorial evolution. GPS navigation, for example, this is a combination of many things: physics, electronics, rocket science to put the satellites into orbit, and software. And in these fields, there are actually many, many things that are required to make a GPS navigation system to work. Now, this has been done ever since. Humans have been smart. Now, one thing is that technology is actually autopoietic, and that's a very difficult word for saying self-creating, which means it reinvents itself all the time. From one technology, another emerges, just like life does, like cells. Cells split into two, but change slightly or more than slightly. And this happens with technology as well all the time. We constantly evolve and constantly improve. There's actually very little cases where things stay the same. And this makes it so dynamic. That's why it is actually able to resist changes of conditions and the environment. So what does this tell us? This tells us that every living species stands on top of a pyramid, so it's based on its ancestors. Secondly, all the future species will be derived from the ones living now. And finally, it's not really the novelty of a species is not what it's doing now, it's what it is able to produce in the future. And that's very important. If we think of Drupal, we have to think of the future and not just of the very near feature that you want. You have to think ahead, you have to think strategically if you want to mimic really biology. And actually you can replace all these words, living species, by technology, and this is true, this is all correct. This is again about combinatorial evolution. First we discover fibers, that they have strength, so we make rope, and then with the rope we discover that friction creates heat, and heat creates fire, and with the fire we can melt iron ore, and with the ore we can make metal tools, and then with the metal tools and the rope we can make an axe. This is a very short example of the GPS combinatorial evolution, but in the Stone Age, right? Or in the Iron Age in this case. Now, one very important question is, what about complexity? It seems that all these things get more and more complex. And that is true. Of course, the GPS navigation system is slightly more advanced than an axe made of iron and wood. But is it always the case? Well, it turns out that it's mostly the case. There is some, if I take back this scheme with the evolution of human life on Earth, you'll see that it gets from very low cells to us. And we think of us being more the advanced species, of course. And this is a bit related to an entropy that's changing, that's increasing. Things tend to be more complicated. But it's not always true. As I said, parasites actually did the opposite. They went from a very advanced species to a lower function. Why? Because they actually gave up some body functions and then used somebody else's. It's also a way of working, and it actually works as well. But it is rather the exception than the rule. But it is possible to simplify things, but it means that you have to use somebody else's complexity to live. So that's the downside of it. Now, there are of course some species that haven't evolved much. Sharks, crocodiles, various plants. Now that is in fact not really relevant. Why? Because they haven't seen changing conditions. If the conditions didn't change and they were more or less successful, they stay what they are. But if the conditions will change, if somehow the oceans would warm up or cool down, I'm sure sharks will change, and so will crocodiles and all that. And it's also applied to some software. We see some old software still being in place, but is that sustainable? Of course not. We all know that this software will eventually change once the hardware breaks down or the people die out who know the software. This will actually disappear someday. Now, one thing about evolution, is it good or is it bad sometimes? Why do you ask this question? Well, I have to tell you a story, and it's actually a sad story with a good ending. Last month, and this is not a joke, a very good friend of mine almost died. And what happened? Well, he choked. He was eating, as we are Belgians, he was eating French fries and enjoying it, but he choked on it. I don't know why. Maybe he was laughing or he's talking while he was eating, which is always dangerous, and he choked in it. His wife didn't know what the Heimlich maneuver was, you know, the trick to get stuff out of your trachea. No, but she didn't know that, so she called the ambulance, which took 20 minutes, and by that time he hadn't been breathing very long, so he was in a coma. Now he got out, fortunately, and he's walking around and he's remembering things, so things look good. But why does this happen? This happens actually quite a lot. This is bad design. We've got our esophagus, or the gullet in English, and we've got a windpipe. They're very close together, very close, so close that we actually can choke when we eat food. And this is a big danger. Why is this so bad, this design? Well, it turns out that this design has a purpose. The fact that it's been like this means we can talk. The fact that we can talk has offered us a very, very big evolutionary advantage, despite the risk. So the risk was smaller than the opportunity. And this also applies to software. So if we evolve software and it becomes more complex and it becomes risky in some areas, you always have to outweigh the risks versus the opportunity. So that means don't be afraid of a condition that might be risky. There may be a big evolutionary benefit, even if you can choke to death, which means you have to be careful when you do certain things. Don't eat with people who tell jokes while you're eating, for example. There are other examples like this. Giving birth, and there are some women in the room. In the past, giving birth was a very dangerous process. Nowadays, with hospitals, it's a lot better, but in the past, many women died when they gave birth. Why? Well, we actually wait quite long before a child is born because our brains get so big and you have to get it out. But a big brain is a big benefit to us. So evolution pushed us this way. Again, the benefit was bigger than the risk. We've got other things. We've got blind spots in our eyes, which could easily be corrected with another design. We've got junk in our DNA, which really doesn't serve any purpose. And there are many, many examples. And every animal and every plant has such disadvantages. And so as software, if you look in software, you will find a lot of junk, a lot of obsolete parts, and so on. And also dangerous design, but hopefully for a purpose. Now, what about the complexity in software? Now, we'll get back to Drupal, because that's why we're here. This is the number of files per Drupal release, and as you see, this has gone up. And this has been shown in San Francisco 2010. We're now 3 years later. This has gone up much, much more. As you've seen in this first simulation, this is really a lot more. And things have really started in 2005. Same with the code size. Now, there's something, and Dries has actually blogged about this, there's something called the cyclomatic complexity. That's a measure to measure how complex is code. You actually count the number of independent parts in the code. But there are many other metrics, and this gives you an idea how complex your code is. And people are debating, is there an optimum? Should our code be less than 10 or less than that or this? And there are sort of religious debates about this. I can't answer this right now, and I think there are certain limits, I'm sure, but the thing is, it's important to measure it. I think it is important to keep an eye on this, because otherwise some parts of the code might indeed become, I would say, bloated beyond a rate that it cannot be sustained or supported anymore. And that's very important. We have a very big community, but there are limits to all we can do. We see this with Drupal 8. We see that Drupal 8 takes really a long time. The contrib modules take a long time. If the code would grow as it grows now, which is more than linear, and we know that our number of developers isn't growing more than linear, we run into trouble, okay? So what the limits are will be determined by the available resources. Otherwise, parts of the code will die off. And that's something we really have to be aware of. So we should cut where necessary in order to keep these things down. So first message is measure, okay? Just to give you an example again, the code, actually Christoph de Jager mentioned it just 3 days ago, compared to Drupal 1, 4,000 lines of code in core, and Drupal 8, roughly 500,000. That's 125. That's a lot for 8 generations of code, but not unusual. So there are many, many metrics, and sometimes one wonders, are they meaningful? Right? And I see a lot of debates that are actually meaningless about it. And then you can say, how many is a flower? Is an orange greater than salty? And sometimes if you read the debates about these metrics, this is the debate that's going on. That's meaningless. But the metrics themselves, some are meaningful, and they have to be observed, I think. One thing about this complexity, there is actually a zone of comfort in this complexity. There's an axis which indicates how certain you are about what you want, and also an axis about how much agreement there is between the developers and the community. And in the left corner, it's very simple. There's no debate, there's no risk. There's also a corner with chaos. We have to make sure we stay in a comfort zone. So our metrics should respect also this. and should visualize where the code is heading, and not the code on its own, contrib modules and core. And you should actually see where we are. I didn't do this exercise. This is an exercise to be done. I haven't seen it yet. I think it's very interesting to see, are we going into a chaos zone or not? I don't think so. I've seen a few good things in the Drupal 8, clean up and so on, which pushes you back again to the more comfort area, okay? Now, there's, of course, a very famous software law, Zawinski's code, a law of software development. Every program attempts to expand until it can read mail. And if it can't, then it will be replaced by code that does. But it looks like ridiculous. And yet it happens all the time. And even with Drupal 8, and I'm not accusing anyone, we're getting there a little bit. Why? Well, we had a framework. With a framework, it's easy to build something that can read mail, right? It happens all the time. Software becomes more complex, you can do more things. And it's a joke, but it proves that things can get bloated if you don't watch out. Now, something very important in evolutionary theories, both on biology and software, is the resilience, right? We asked the question, will Drupal survive? Another 10 years, 20 years? Well, it will change in 10 years. Drupal won't look like what it looks like today. It might still have particularly architectures of today's Drupal, but it should be resilient. Resilient is a change that is sudden, unexpected. For example, Drupal is built on PHP. What if in 3 years' time PHP would disappear or not be supported anymore? What if the community of PHP would collapse? I'm not saying it will, but what about in 10 years' time? So, or MySQL. Maybe suddenly MySQL becomes, disappears or changes or whatnot. There are many things that can happen, things we can't even imagine. The question is, how resilient are you? Resilience could mean we port it to some other platform. We do it in Java, for instance, but that's also a joke, I guess. But in any case, it's very important that you program everything to fail. Always keep failure in mind. And I don't mean really software failure, like trapping errors. I really mean if things can change, right? Always keep in mind, what if we change this database by another one? What if we don't use HTML anymore, but something else? What if we don't use a relational database in the first place? Or but a new NoSQL database? Things like this. Now we get to the complex adaptive systems. And that is something that applies to physics, to biology, and also to software. Complex adaptive systems in biology actually are influenced by many, many areas. It's actually on top of all kinds of scientific disciplines. Sociology, chemistry, genetics, ecology, philosophy, the weather, whatever. So all these things might influence what your system looks like. And your system has to cope with changes. And the same is true in software. Marketing, the competition, the sales, the organization. We just heard it in the keynote. Management, innovation, leadership, many things. Hardware, software. So all these things might influence your system, and designing for failure isn't easy. But it requires that you have a very open mind and you have people with a helicopter view of all these things. And they should have a say in what you are developing. And as we said, it's not the strongest species that will survive or not the most intelligent. It's the one that's the most adaptive to change. The dinosaurs lived for millions of years until suddenly this asteroid hit the Earth and changed the weather for 2 years or so. But that was enough. And small, futile mammals took over. And this was our chance because we could adapt. We didn't care about the weather. We are warm-blooded, which is a huge advantage, although it's also a disadvantage in many ways, but it is, in this case, a big advantage. So, all this, the question is, how can you ensure that this is actually okay? I mean, what about this adaptiveness? Well, it's been studied. There's been a lot of study on life evolution and on adaptiveness. And maybe some of you have been playing 20 years ago with games called Life. And life was a very simple simulation with cells, and the cells could interact with each other's neighbors with very simple rules. And they could die off if they were alone, and if there were 3 surrounding neighbors, they would replicate or reproduce. And you could have very nice simulation of like cells evolving. Nowadays we have stronger computers and we can do more, and we have now, for instance, Boyds. And anyone from New York here? No? That's actually New York slang for birds, but I can't pronounce it too well. This is just, I'm not going to show you the whole movie. This is actually a very simple simulation. It uses very simple rules, only 3 rules. And you can see birds, a flock of birds, evolving and flying through landscapes and doing things. And there are many movies of this. You can look it up on the internet. I think it's very beautiful, but it's also very interesting because you can try things out. For instance, suddenly you have a bird of prey. What does it do with the flock? Will some get hit, some get killed, but will most survive? What if a volcano erupts? What if suddenly they are caged? Will they get out of the cage, out of a maze? So I've seen very interesting simulations of this, and it's all very interesting. And according to, with certain rules, you have a much better chance of surviving than with others. So this is just a short, now a short demo. Obsolescence. Obsolescence is actually also a way of disrupting the environment. We know many cases. We used to have a tail, we don't anymore. We have a small tailbone, and I'm sure in another 500,000 years it will be gone, which is good if you fall on it, because it hurts like hell. We've got wisdom teeth, but that doesn't really serve a purpose, and we've got many other things that actually don't serve a purpose anymore. But in technology, there are many examples also. We don't use floppy disks anymore because there's something better. We don't use Walkmans because there's something better. And these disruptive things are more difficult to predict, but you can simulate them. And what I didn't say yet is I had this nice Boyd simulation. The question is, can you do this on software? And the answer is yes. You could also try to simulate with software the behavior of software systems if things would change. And this is still in its infancy. But I think it's very interesting in order to measure how adaptive your system really is. But one thing is sure, that the rules are always very easy. These birds that you've seen behave according to very simple rules, actually just 3 rules. I don't know them by heart, but I've seen the code. You can change that, and that already explains a lot of the behavior of, for instance, birds in real life. They don't have a big brain. They just use very simple triggers to control their muscles and the way they fly and the way they behave. Which means that in order to simulate software behavior and its adaptiveness, you can also use fairly simple rules to do that. Now, there's been a lot of study on this adaptiveness, and there's what we call the Lehman's laws of software evolution. First of all, Lehman categorized software into 3 categories. Software that's built to spec, really, precisely to spec. That's not what we're talking about. You got also the P programs that have to do a task. For instance, play chess, a very simple task. And E programs, they are built to perform some real-world activity. And that's what we're talking about. Drupal is an E program, okay? Biology also applies to that, and so does Drupal. And the Lehman laws, and I'm not going to great detail into great detail, they say what you have to do. There's always continuing change. We know this. You have to adapt, or otherwise you will become less satisfactory to clients or users. The complexity will always increase, as we've seen. And unless you do something about it, complexity will increase. You really have to do it actively. There's always self-regulation. Somehow this thing regulates itself. It's very important that there's organizational stability. If there isn't, the software might perish. And that's a good thing about Drupal. We've got the Drupal Association, which actually controls the organization a little bit. It's a stabilizing element. You have to have conservation of familiarity. What does that mean? Well, we just don't have developers. We have salespeople. We've got users. We've got marketing people. We've got system administrators. If you would radically change your software, it would become unfamiliar to them. And that is dangerous. So
you have to preserve some familiarity, okay? So be disruptive, not too disruptive sometimes. You have to ensure continuing growth. You have to make sure that your quality actually goes up, because if you don't do anything, it will go down. It will be perceived like that. And you need a feedback system, feedback with loops and iterations from various channels in your organization and your clients and so on. You have to listen to them, okay? And there are lots of dangers related to software development, and we have to keep that in mind. There's the inner platform effect, which means that developers will tend to put in features that they already have on their operating system or somewhere in development environment. They want to put this in the system, and then it becomes bloated in a way it shouldn't. Anti-pattern, that's a very complicated thing that entails a lot of things like the analysis paralysis dilemma, cash cow, death march. You know what death march is? It's when everybody in the organization knows that the thing will fail except the CEO, and things will still continue. That's a death march, and nobody dares to tell him. Happens. It's not the case in our community. Technical debt, you sort of start building things, and oh, we still have to do this, and we have to do this, and we postpone it. We build up debt, technical debt. We'll do it later. No, it won't happen, okay? Very bad. It's kind of a rotting process from inside. Software brittleness. Software becomes more brittle. You have to reinforce it all the time. And the complexity trap. I think you know what that is. One thing to keep in mind when designing software, and also open source software, is that farmers don't grow the crops. This is the link again with biology. No, they create the conditions for crops to grow. And this is very important. So we come to 5 conclusions. We have to scrutinize every design decision with respect to the dangers and set a very good growing condition, or conditions in plural. We have to watch the code complexity. We have to dare to simplify. Otherwise, it will be bloated. It will become unsustainable, keeping in mind also the size of the community, potential size of the community. We have to understand the good evolution and the bad evolution. And we can accept bad evolution if the benefits are sufficiently big. All right? But keep in mind resilience. We have to embrace diversity. In life, there have always been forks. Need to say no more. And you can like it or not, it's actually a natural thing to happen in evolution. It may perish, it may go away, but there's not one shark, there are tens of types of sharks. They're all successful in their own environment. They might compete, they might not. It happens. And then finally, we have to react fast enough on all the environmental changes. Fast enough. Not too fast, not too slow. Now, there's good news. I've been watching Drupal 8 lately, and I've been impressed. I've been drooling, okay? Many of the things I said actually apply. Drupal 8 is in a good shape with respect to these evolutionary considerations. However, except one, the bad news. I think it takes too long. We detect it. On the demand side, people are starting to complain, customers. It takes too long. They sense it. Things that are in Drupal 8 are overdue for a long time. They're coming, they're all coming, but it will take a long time still to implement. A year is a long time. Now, a year is long and it's short, but it's something to consider in future release management. There has to be an optimum. What is the optimum cycle time? And sometimes you have to maybe accelerate or split up. I'm not going to detail here, but if it takes too long, it's dangerous. We waste opportunities, and competition isn't sitting idle either. And we need to stay on guard, because it's okay with Drupal 8. Inevitably, there will be a Drupal 9 and a Drupal 10, I hope. We have to keep these things in mind. Try to find out good metrics. See where we are in the complexity scheme. See that we don't overdo things. Reduce complexity if necessary, and so on, and so on. Don't fall into the traps, the dangers that I've pointed out. If you do this, Drupal will have a bright future and will never be a dinosaur, and it will be a mammal, like we are, a good one. It will change, but these are the conditions for it to happen. That's it. Any questions? Okay then. You can always mail me or tweet me.
Hi. Hi everyone. I think I'm ready to start. Let me at first thank you for being here because as my previous speaker said, there are like quite nice competitors in other rooms, and that was a hard competition. So my name is Mikhail Vink, and I'm from a company named JetBrains from PhpStorm team, and I'm product marketing manager for PhpStorm ID. Well, I hope that after this manager marketing in the position, you don't begin to go out of the room, because actually I'm a developer and I have more than 5 years development experience in PHP. So I'm not going to give a marketing talk or something like that. So the session today is named Drupal development using PhpStorm, and I'll try to overview what can we do for you in order to make you, Drupal developers, more productive. So first of all, there are some exciting news to share. Probably you already have seen them from announcements the previous week made by both Drupal Association and JetBrains. And the first one is that JetBrains is now a Drupal technology partner. And that means that we are giving back to the Drupal community more. And we are really happy to do so, because we can support the development of Drupal and Drupal Association. And that's really nice, I think, I hope. The next one is that on Friday we announced that we also proud to offer core contributors of Drupal, Drupal core, Drupal modules, and Drupal themes, PhpStorm free licenses for open source development. We've been doing it for quite a while, but as Drupal community is quite big, there are a lot of open source contributors. We needed to standardize the program and change the workflow a little bit of getting these licenses, so I hope now it will be easier to get it. So if you are a top contributor, you can check the rules in Drupal Association or JetBrains websites and apply for licenses. And one more news to share is that we are now at DrupalCon, the 3rd time, and we are really happy to support the conference. So at first, I hope that's not for you, but I'll first tell a bit what is PhpStorm, and I'll be going from the presentation to the IDE, because I really broke the rule that you don't need to show anything live on the conference. I don't believe so, so I didn't want to make these promotional videos or something, so I will do anything in the IDE, showing you just here on my laptop without any pre-recorded videos. So basically PhpStorm is an IDE integrated development environment for PHP, and it contains some nice features for code completion. It deeply understands PHP code and also provides code refactorings, type inference, and debugging features, version control support, and all the rest. So that would be quite weird to list all the features here. So yeah, it's a little bit blurred, but it seems I can do nothing about the projector. So yeah, now we know what is PhpStorm, and let's talk a bit what can we give for Drupal. Well, first of all, the next version is going to be released only in 1 month or about. So it's October, November, it will be version 7. And for version 7, we actually have in mind quite a bunch of features for Drupal developers that are well spread in Drupal community like Drush, Coder, and some others. And one more nice thing is that all these features have been done by us just talking to you, to community of Drupal during the previous two DrupalCons. And I think that this thing really makes this support special because we didn't made it on our own. We didn't invent some features, but we wanted to solve your problems. And actually, all we do at JetBrains is solving problems of developers because, well, it's nice to have some features, but it's better to solve some problem and to make you more productive. And last but not least thing is that you still have this well-known IDE at your fingertips. You have all the features, VCS, debugging, all the rest. So let's go to some hands-on. So first, development environment after configuration for Drupal. And let's check how can it be done. So first, if you want to create our new project, Drupal project, we just go to create a new project, and now we have a Drupal module. And when we select that we would like to create a Drupal module, the IDE will ask us to provide the path, version, and all the rest, so it knows about your Drupal distribution. So basically what do we need is just to show where our main Drupal is located. So let me show it. Yeah, and now the IDE supports version 6 and 7, and support for 8 is coming, but when 8 will be like closer to the release, because now it's not so stable to make support for that. So we just can easily create a new module or also integrate Drupal plugin in modules we already have. And what the IDE will do is creating the basic skeleton project, so it's info and module files, in order to ease setup of the new module for you. Also, it will configure the IDE, because some configuration needs to be done in usual terms. But now, when you create specifically Drupal module, it will configure coding standard for you, coding style for Drupal. Also, it will configure file types, because info and module and install files, they are not usually used the way they are used in Drupal. So it's good to configure them straightforward. And also it includes all your Drupal installation as an external libraries, so that you get all the code completion for Drupal API and all the rest. The next thing we have for quite a while is built-in Drupal code style. So basically, following coding style and coding standards in Drupal community is really important, because Drupal is all built on open source, and there are really a lot of contributors. And if every contributor to core or to some module would use their own coding standard, not a Drupal one, that would be really a mess, and you won't be able to normally understand the code and read others' code in order to maintain the module. So basically, code style is a bunch of predefined rule sets, and in PhpStorm we have this predefined rule set for Drupal. But nice thing, and I'll go to I'll go to another project to have support there for that. Just a second. Yeah. For example, poll module. When the Drupal coding standard and coding style is selected in the ID, everything you do about the code, like code reformat, it will be done conforming to Drupal coding style. And also, there is a very nice feature when you commit something, and PhpStorm supports Git and other VCS, but in Drupal, mostly Git is used. So when you commit, you can check reformat code, and the code will be automatically reformatted according to Drupal code style. Also, quite a big pain we wanted to ease for Drupal developers is working with hooks. Because, well, hooks is a very nice system, but it's not really native PHP, because it's not really native PHP function. It's a kind of an alias for the function which depends on the module you are declaring it for. So there is a big problem for any editor, because you can't get code completion as there is no native PHP function for that. And also it's difficult to navigate because you need to understand where is hook invocation in your code, and also you want to get documentation right away, because there are too many hooks in many modules. You can implement your own, you can documentate your own hooks, and it's really a mess when you have a big project. So for example, when we let me zoom a bit. Maybe, yeah, it's a bit seen. So when we just would like to make some hook declaration in your module, we just make it function, and we have hooks indexed completely from all the modules and from the core. So basically, you can get a normal hook information about all the hooks, and also you can get all the documentation for hooks even while you're just switching between them. So you don't need to go to other files, search for your hooks and all the rest, because well, it wouldn't be so convenient. And moreover, there is navigation to hook invocations. So there is just this green icon on the left in the gutter. So you just press it, select what invocation do you want to navigate, and yeah, we are here. We just navigated to this module invoke string and can check what's going on. Second problem we wanted to solve is how you get documentation about Drupal API, because there are some hooks, but apart from hooks, there are just a lot of different API functions from the core Drupal API, and it's quite understandable that you can't remember all of them. And what we want to help you about this Drupal API is to easily navigate you to the website, not to spend a lot of time going to the browser, going to Drupal or going to search and all the rest. But here you can just select some Drupal API function, and from the context menu you can select search in Drupal API, and it will open browser, and you will be navigated right to the documentation for this Drupal API function. That's pretty convenient and fast. The next nice tool which is integrated is Drupal Coder. That's a very interesting tool because it really stands alone, and it helps Drupal developers to check if their code conforms to Drupal standard, coding standards. I mean, and basically it can be run without any integration with anything, and it can check your Drupal code straight away from the console, for example. But it's very nice to use it with PHP Code Sniffer. PHP Code Sniffer, that's another tool which can check if your code conforms to other formats, let it be peer or something else. And Drupal coder rule set actually can be integrated in this PHP code sniffer, in this way it is very easy to integrate it right in the IDE. So the only one thing we need to do is configure code sniffer in PhpStorm. So basically it is providing the path to PHP code sniffer, and it validates it that the version is okay, and then we just need to turn on inspection for that, select that we want Drupal coder tool inspections to be shown in the editor, and right in a couple of seconds it provides you information right in the code about code style violations. Well, which is also very convenient because you are able to check all the code violations and fix that. For example, here I have wrong spacing, and I don't have a space between before the brace, and also we can easily reformat code if you broke anything. Yeah, and also we can inspect code, whole project, for example, run inspection by name for code sniffer. So we check only these violations of Drupal coding standards, and it can be checked for the whole project, and you will get information about all the violations. So yeah, for whole Drupal distributions it takes a few seconds. Yeah, so we've got like 800 coding standards violations here, so we can go one by one and fix everything and then commit, and it will be really nice for those who will be reviewing your code. One more tool we integrated is Drush tool. Drush is a very handy tool for Drupal developers because it is actually a command line tool, and it has nice features like upper-tagged styled comments to work with packages, to work with your Drupal distribution. You can update it, you can add some module themes, translations, all the rest. You can also migrate databases or perform some administration issues. And now you actually don't need to leave integrated development environment to do so, because now it contains all the comments for Drush, and you need to select in settings that you want to use it in the project or configure it globally. And then as we type Drush in the command line tool console here on the left, for example, I type Drush help, and yeah, it runs it, and it provides all the results here. The same way we can make, for example, Drush catch clear. It will tell us what do I want, for which one should I perform it. I select it, cache was cleared, and we are done. We don't need to switch to console, we don't need to switch anywhere else. And one more thing integrated in PhpStorm is Drupal.org issue tracker. I think many of you are doing open source development, and Drupal.org contains a very nice infrastructure for doing so for Drupal project, and they have also issue tracker integrated there, and that means that would be quite handy to have information about issues you're working on right in your IDE, and we have a configuration to do so. Well, there is no predefined one, but it can be easily configured for Drupal project. And even when you commit something which is associated with this issue, it will be commented that you were working on this issue, so you don't need to annotate or commit on your own. So for example, I have it here in my project, and I can switch between tasks. And for example, I just opened tasks here, and it lists all the tasks from Drupal issue tracker I choose. So I choose core project. So there is, for example, the first one, convert system themes page to a new style control. And I can search it, find what I need to work on, select, and I can create a change list, for example, for version control to be based on this issue. So that means that all the changes I perform when this issue is selected in the IDE, they will be in one separate change list, and it will be committed with edit command that's for this issue. So that's quite handy. You don't need to go to the issue at Drupal.org one more time to check what's the name and what's the ID. You just can do it right away from the ID. But yeah, that was about mostly Drupal 6 and 7. And that's nice, but Drupal 8 is really coming, and that's not a long time before it will be live, and we will also need support for that. And we know that the biggest change in the next Drupal is that it contains Symfony components, and there are some very nice news coming with this support. First of all, we have our open source Symfony plugin for PhpStorm written by community, from our Symfony community basically, and they provided really a bunch of features for Symfony components. So it related to some code completion, navigation, annotations, and many others. And also Drupal 8 is, as I know, is going to be distributed through Composer tool. That's package dependency manager for PHP, and that's really nice news because you can manage your dependencies in the project really effectively and easy, so you are not screwed up really when you update something. And there is also UI in the IDE, so you can just select, find for Drupal 8 and download it, find dependencies, everything will be installed straight away by the IDE. And there is a tweak support as a part of the IDE by default, and also in this Symfony plugin there is support for tweak templates, which are going to be default templates for Drupal 8. And it means that you get all the code highlighting, or you get all the code completion, navigation, and other features for new tweak templates. Because when it comes to Drupal 8, it's a bit more complicated, and Symfony components also require some help from the IDE, such as Drupal hooks also require some support from the IDE, a special one, and that's quite difficult to easily maintain it without any information about your code. And one more thing which is also coming to Drupal 8 is PHP unit testing system, and nice thing that it's now a standard in the PHP community, and there are already some tests developed for Drupal 8. And for example, we can get the Drupal 8 distribution as I done here, and we can run tests with coverage. Well, you see there are tests running, and we can see what's going on with our tests. We can navigate to code, to the source, for example, if something is failing, and we also can see how much code of our application is covered by tests. And that's really very nice to have this test running right in the IDE before you deploy your application. So, is there anything else about Drupal support? Well, basically, that were mainly all features we needed especially to implement for Drupal. But there are many other features and many other problems solved which you can use, and they are just out of the box in the IDE, and they are just okay for any web applications, for any PHP applications, let it be Drupal, Symfony, or something else. So you can take advantage of debugging, you can take advantage of VCS integration, or for, I don't know, HTML, CSS, and JavaScript live edit features, or something else. There are really a lot of things you can do about it. So if you haven't tried it, I would definitely recommend you to do so. Because as we actually realized on this conference that most of code committers of Drupal now use our IDE, and yeah, thanks for them. Thanks to these guys, because they're doing a great job. So if you would like to learn more, there are some materials. The first one is basically to learn more about PhpStorm. It's jetbrains.com/PhpStorm. And the next version with Drupal support is already live, even 1 month before release. You can download the public preview, it's stable, and we still are going to make some fixes to Drupal support, but it's quite usable already, so try it now and provide us your feedback in the issue tracker, because we will be working on that. And also there is a full Drupal development using PhpStorm tutorial on our website. You can easily Google it also. And it contains information about how to use every feature for Drupal development. So yeah, that's the first place you need to go, I think. And what we want to do from the side of JetBrains PhpStorm team is that you develop with pleasure, because we would like to automate all the routine tasks you need to perform to make your Drupal development really interesting for you, so that you don't spend a lot of time on routine tasks, but you spend time being creative and making some cool stuff. And also, please rate the session at the DrupalCon website, because it's really important for us to know what do you think about it. And there is also one more nice event tomorrow. It's Drupal Sprints, and I would recommend going there because there will be a lot of coders around, and I'm sure that my colleagues from Drupal community will be happy to help you with PhpStorm as well. So yeah, that was pretty it for today, and once again, thank you, and develop with pleasure. You can easily find me anywhere, Twitter, email, or something like that. So I will be glad to hear any feedback or any features you would like to have in our products, or just anything you would like to talk about. And we are still here for a whole exhibition day. So just come by our booth, and we have some discounts and licenses to raffle. So we will be happy to talk to you. Thank you. Thank you. Probably you have some questions? Yeah, no questions. Thank you. Yeah? Actually, we support PHP-doc annotations, but as I know, Drupal 8 is not really about PHP-doc, isn't it so? Well, actually, we basically support PHP-doc, so it's a standard for annotations in PHP. Let me check. Drupal 8. Well, it seems, well, it's not. Yeah, that's PHP-doc I see here. So yes, we do. We provide some help for that. Yeah, you see there is like completion. What we can put here. It's context dependent, so it's not going to provide you information you don't need in PHP-doc. So yeah. And if there are some Drupal-specific features about these annotations, we will have a look closer to the release when they are just decide on the format of them and check that it works well. Yeah, thank you.